going to go through a couple different steps of like practicing things as we go through this problem. So if you will take the numbers that are at the bottom and type them into a list. Where's the first place that you should check to see that you know you didn't mess up? So the problem tells you there are 29. You should check and make sure that there are 29. All right, so it says method 1, and it says some blanks to fill in. But I don't want to, I want to go past that. I want to be writing like right here below generally using. All right, so the first thing that we're going to do is draw a histogram. So I'm going to write my steps here, not actually do it on this paper. Now, if you follow along, if you ever read this in the book, it says you can do a stem plot. I think it's the book that says you can do a stem plot. That's fine, but I'll show you why I don't like you using that one. All right, so we've got our calculator. We've got all the numbers in it. Let's use our calculator. Now, did I give you any details about a histogram? What are some things on a typical problem that I could tell you if I tell you to make a histogram? I could give you the what? What information could I give you? What? I could tell you this is how many classes I want, or I could tell you what? The class width, or I could tell you nothing. And these kind of problems, it tells you nothing. So let's graph it first and see what the calculator does. So where do I go to graph this? Second, stat plot, top left. You want to make sure plot 1 is on. You want to make sure it looks like a histogram, and you want to make sure it's in the right place. Your frequency stays 1. And most of you are going to see absolutely nothing. What should you do if you see nothing? Zoom 9. Zoom 9 is always, always, always your first option of, if it doesn't look right and you think you graphed it right, zoom 9 and it'll probably fix it. 90% of the time it's probably going to work. And now, as I'm talking, I'm going quick over something I've taught you how to do already. Find a histogram. There are going to be some of you who are like, I missed that and I still don't remember. You better turn around and figure out somebody else while we're going. Don't just sit there. I don't mind y'all talking to figure out calculator stuff while I'm talking. All right, so we're going to check to see how the calculator did it. So how do I figure out what that first bar represents. What button do I push? Trace. So the way the calculator did it is that first bar starts at what? 4.88. How many are in that first bar? 1. And it goes up until the next one starts at 5.04166667 something. Well, that sounds terrible to deal with. What can you tell me about the shape of that graph in general? Looks fairly unimodal, fairly symmetrical bell shape. Let's change our class width. How do I change my class width? What button do I push first? Window, X scale. Right now it has the X scale of third button, no. Like 0.16166666 something. Let's try to make life easier on us. What's something I can pick that's close to that? That doesn't just go like a repeating number. Okay, so let's go 0.15. Let's try that. How does that look?
How many are the 60?
Just like type 0.15 over it. How does that look? Even more symmetrical bell shape, right? Let's go back to window again. Let's mess around with a little bit. Let's type 0.2, just 0.2. Now that one went really high. That's fine. What we're trying to do here is we're trying to see if it is close enough to use normal that it would make sense to use the yellow chart to make estimates. So not like it has to fit a perfect bell-shaped normal curve, but if it's close enough, it would at least make sense to be like, well, we should be thinking for like about 16% would fall here. So of the three graphs, the original 0.15 and 0.2, which do you think proved that point the best? 0.15. Just of the ones we tried, I think 0.15 looked like it was the best. What?
What point did it?
I thought our egg scale 0.15 was the best one.
To prove what?
Like the closest to like the normal curve. This is why I prefer this over a stem plot, because there's nothing you can do to make a stem plot look better. This you can manipulate and use the one that looks best for you. Also, now I don't have to deal with all those like decimal numbers. I would literally graph this one as just the numbers that it gives you, and then I don't have to go to 2 decimal places. So on the right-hand side where it's blank, let's go ahead and sketch this graph. So we're going to practice on how to label the graph and everything. So in your space on the right, we're just going to say histogram of, what are these, density of the Earth, right? So labeling my x-axis, where do I start? 4.88. What is the next number that I write? So go ahead and write these in. Should be spacing equally here. I'm just going through trace to get these. What's the last one I'm going to write? What? 5.93, because that's where my next bar would start that I don't go to. All right, what is my highest frequency that I need to get to? There's my x-axis label. What's my y-axis label going to be? Super basic. frequency. Now these should have like marks here, but I was trying to type it so I'd space it better. So on your paper, you should actually have these little lines to show you where each one of these is. What's the highest frequency I need to get to? How do I figure that out pretty easy? Just go to the tallest one and see how many there are, which is 8. And now we're graphing. So the first thing here is we're just making a histogram. But I encourage you to manipulate the histogram a little bit, if nothing else, so that my x-axis, I don't have to write out a whole bunch of decimals that I don't need to write out. Change it to something that doesn't have as many decimals so that I don't have to worry about that. So this is why I prefer teaching histogram in the calculator and manipulating it, is because it can help you with this to kind of start to prove, or this part of it, so you can start to prove your point. Not sure how well y'all can see that frequency. And then let's go ahead and go down below method 2. So for method 1, our first step was draw a histogram or stem plot. For method 2, it's the same thing. So it's still going to say method 2. It's got some fill in the blanks. It really recognized my handwriting. That's impressive. It's got the fill in the blank stuff, but I still want your step 1 to be draw histogram. So regardless, you have to start here. Now, the purpose of what we just did is basically, let me see what the data looks like to see if it is even worth my time at all whatsoever to see if using a normal approximation would be helpful at all. If you get something that's like all the data is over here, and you've got something crazy like this, do you think using that yellow sheet to approximate what percent is in the top would be helpful at all? Because it's nowhere close at all whatsoever. Now, does it have to be perfect? No. If I give you a problem to go through all of these steps on a test, I'm not going to give you all of these steps to go through to where the first step says, okay, don't keep going. All right, so we basically look at this and say, should I continue or should I not? So up here, it says first check. We are first going to check the histogram. To see if it is, and these seem like the same thing, but the book words it this way, so I keep it this way. Both bell-shaped and symmetrical about the mean. So we would look at the graph that we just made, and we would literally write off to the side, fairly bell-shaped, symmetrical about the mean. Like you would clearly write that those are the two things that you check. So let's go ahead and do that over here somewhere. And I would imagine that to most of you, those seem like the exact same thing, and you're okay with that, but you actually need to see that you check both of them. So that means continue. Now, for method 2, it is also going to be histogram, checking for bell shape, and symmetric about the mean. So that top line of method 2 is the same. So method 2 is also first check histogram to see if it is bell-shaped, symmetric about the mean. Now, beyond our class, or actually in the practice of statistics, most statisticians never go with method 1, and they go with method 2, and they never even consider method 1. It's not necessarily as helpful. But as far as this class, I prefer you use method 1 because it makes sense. You're thinking about it in pieces, and we don't get into method 2 enough for it to make sense to you. So what we're going to do now is if I say, okay, this data looks good, we're going to use the yellow sheet. Well, the yellow sheet is made up of what? What is stuff on the outside?
Z-scores.
Z-scores. Well, do we have Z-scores right now? No. What can we get from that list that we're going to need to use to find Z-scores? What is our equation for Z-score? X minus mean divided by, which of those can I get out of that list? Mean and standard deviation. And I'm going to put one more decimal place, one more decimal than data. It avoids a lot of issues by doing this. So how do I find that? So I'm doing calculator review as we go. How do I find that? How do you find mean and standard deviation in calculator? First button you click is what?
Stat.
stat over to count, and then you click one variable stat, make sure it's up the list where your numbers are. So how many decimals does our data have? It's written to how many decimal places? 2. So we're going to write ours to 3. So we get an X bar. So these are my steps. I'm going to write underneath here. You can, if you want to, this is step 1. Step 2. So step 2, I get an X bar of 5.448. Y'all get the same thing? And a standard deviation of what? What letter is my standard deviation for now? So it's the one that is 0.221.
Well, actually, say graph minus is 2.222.
Say that. Say it again.
On minus is 0.222.
Are y'all getting 222 or 2209? Okay, then it's one of your numbers and they're different. Let me go ahead and give you a hint. Obviously, you can't do this on a test or quiz. Everybody's got the same numbers typed in a calculator, right? Or should. This is going to happen where somebody doesn't. And there's a really easy way to check this. I could just go to sort my list, get somebody else to sort theirs, grab their calculator, and click through them really quick, and you'll find out the one that's wrong. Just as a heads up from now on. So step 3. Did I write that in the other one? Did y'all write this method 1 or method 2? That should be method 1. That really wasn't wrong. But. Or you can switch them if you want. Doesn't matter. Define mean and standard deviation for method 1. Different spots. Alright, so let's say that we're trying to use the yellow sheet. What's our brief version of the yellow sheet? What rule is the brief version of the yellow sheet? The empirical rule. Well, if I were to draw the empirical curve, what numbers do I need to get the bottom? If I were to draw an empirical curve, what numbers would I need to know to draw that bottom? So what you're going to do here is you're going to draw this basically pretending like you're getting ready to do the empirical curve, but you never draw the curve, you just do the number line for it. So you're going to draw a number line, and only the number line. Using your mean as the middle. And then 3 standard deviations each way. So that's the number line for the empirical curve without the empirical curve drawn on it. Now, this always throws 2 or 3 people off. Did I use mean and standard deviation to make this histogram? No. So this number line is going to look kind of similar, but it's not going to be the same as the one we're getting ready to do. I'm going to start on a different slide just so I have room. So you keep writing underneath that. Step 3.
You just wrote step 3.
Yeah, I'm doing step 3 right underneath, like here. Alright, so I've got my number line. And I start at 5.447. Perfect. Thank you very much. What were we at? 5 point what? What was this? Wasn't it 5 point something?
448.
I think I did this in my other class and not this class. It's just one of those little things that goes a little bit quicker. Type in the number 5448 and hit enter. So literally all it's going to tell you is 5.448. Alright, now don't type anything else and just go straight into plus 0.221, and then you can hit enter 3 times and it'll give you the next 3 numbers. Just calculator stuff if you didn't know this. So going this way, that means my next number is 5.669. Here's going to be 5.890 and 6.111. I can do the same thing, 5.448, hit enter, and then do minus 0.221 and hit enter 3 times. I'm going to come back to this if you're looking at mine and not done writing it, that's fine. Alright, so our step 4, and these steps should be like dumb steps, but I've not written steps out in the past and people just get confused about where they're supposed to go. So find what percent of data falls between each number you wrote on the number line. So find what percent of data falls between each number we just wrote on the number line. So basically I've got to figure out how many numbers are between 4.785 and 5.006. So what would be helpful with my numbers if they were what? If they were in order. So let's sort it. So stat, sort A, this one, enter, it'll say done. Stat, sort A, this one, enter, it says done. You go back in, stat, edit, and they're in order now. Now, the first option that I technically have is how many numbers are below this. We just didn't have any out there. But all of a sudden somebody gets one and they just don't realize they wrote a number there. So none are out there. I didn't really need to write that. How many are between 4.785 and 5.006? Just one. How many numbers? So now I'm going, how many numbers are before I get to 0.5227?
2.
How many numbers before I get to 0.5448?
11.
How many did you get for the next one?
Nine.
How about 10?
I got 10.
Are y'all in agreement? 10?
Yeah.
How many are here? 2, 4. And how many are here?
Those numbers don't add up. It's only 28 numbers in there.
4, 5, 6, 7,
I think there's 11 on the where there is 10. Pretty sure I counted 11.
This one should be 11?
Yeah.
Anybody disagree with that? 11 and 4? Or 11, 11 and 4? Yes, no?
Yeah.
Alright, so back up here where we are in method 1. We are first checking the histogram to see if it's both of these things to start our process. This is where we say, is it worth it to continue or is it not? Then I go through and make my number line and put my numbers on there. So what I'm going to do now, trying to word things the exact same. You are generally using your drawn number line data. I don't know what else better to say that. A number line percent. So using the percentages from your drawn number line, checking to see if I'm just going to put it underneath. It is close to, and we said our generic for the yellow sheet is empirical. What are my numbers from empirical rule?
6 to 96 and 99.7.
So now we're going to compare what we got here. I said percent, but we don't have percent yet. To these. That says 0.7 on them. Kind of hard to see it there. So under here, I'm going to write a chart that compares these. So I know that I'm dealing with 68. I'm going to write more. You might not want to write until you see where I'm starting. What are these numbers? If you don't write something like these are the empirical rule percentages, I'm not going to give you credit for that. What does this say? 68% is
Percent standard deviation.
within
Within the standard deviation.
of. So I was specific here. I said within blank standard deviations of mean is 1, 2, 3. Number of standard deviations from mean is fine. So now I want to compare our data.
What do you mean with number of standard deviation thing? Because the 68, 95,
This is, here's your mean. one this way, that is 68%.
So we would have put 2 right there.
Within two, it doesn't say direction. 2 left or right, 1 left or right.
Yeah, so within 2.
Within 1 in either direction.
Oh, I got you.
Alright, so now we've got to find percentages for our data. Now, here's our mean. So how many of our numbers are within 1 standard deviation of the mean? 22. It's here to here. If you need to, you probably don't need to do what I'm doing here, but this is where my 22 is coming from. So, 22 out of how many? Which is what percent? 35 point what? Alright, so how many are within 2 standard deviations? So I've already got 22, 24, 28, or not 1. Which is what?
26.55.
What am I going to write here? Which is, now we only have 29 numbers. So for every one there is, it's counting for over 3%. So we don't have that much data. Is 100 close to 99.7? Yes. Is 96.55 close to 95? Is 68 close to 75.86? Don't be overly critical. Does that seem so terrible that this doesn't look like it works? Follows almost perfectly, sways a little bit, but we're saying, is it worthwhile to use that to guess about this percent is this? That seems pretty reasonable. So here, we would say we can use normal approximation. I want to word this the way I usually word it. I can't remember which way I would usually word it. I'm basically saying since those numbers are close. Since our data appears to follow closely to the empirical rule percent. So now I can literally just give you a list. You can then determine if you should use it as normal. Then you can find its mean, find the standard deviation, find the z-score of anything in there, and find the percentage about that would fall within whatever data that I gave you. With me literally just giving you a list of numbers, you can go through all those stuff. Now, something like 40% up here is not what I'm looking for. So don't be overly critical there. Basically, is it so terrible that it wouldn't make sense to be helpful at all? Or is it close enough to where, I mean, I'm not going to bet money based off the percentages, but it might give me a little bit of insight. So method 2, I need you to know about method 2, so I'm going to show you, but I wouldn't encourage it, but you're allowed to use it. So with method 2, step 1 was draw a histogram. Step 2 is you're going to label your axes. Your x-axis is your x values in context. As your values in context. So like for this one would have been density of the earth. your y-axis is z-scores. Which means for all 29 of these numbers that we just did, you would have to convert each one to a z-score and then graph it versus its original value. So step 3, graph all x values versus its corresponding z-score. The most important part of this entire method 2 that I need you to know is this second thing. This whole thing is called a normal probability plot. And if you graph each of their x values versus its z-score, the graph is approximately normal if the normal probability plot appears to be linear or fairly linear. And that is the thing that you have to know. If I say, if you are checking for normality, the data is approximately normal if the normal probability plot is what, and you would say linear. Like, that's the thing you have to know. Now, let's think through this. So we're actually going to do this, at least theoretically here. And I need you to find 29 z-scores. What do you know about the method of finding each of these z-scores? What about the equation method used to find these z-scores? Are they similar or not? What is my equation for z-score?
X minus mean.
X minus mean divided by standard deviation. Well, what of that is going to change from value to value? Just x, right? Which means if you repeat a mathematic something over and over for something you already have in a list, use a list to do it. So our list 1 right now are our values. So let's go back to stat edit and click on list 2. And you have to be up here highlighted. So we're going to get it to graph each of our z values in list 2. So while list 2 is highlighted, I type in what? Where are my x's? What is my mean? Divided by
0.22.
and when you hit enter, it'll find the z-score for all 29 of them at the same time.
And how did you find meaning of a bunch?
That was what we did when we did one variable stat that we had done earlier. Alright, now go to second stat plot and click on plot 1. We actually want to graph this like it's a scatter plot. So we're second stat plot, plot 1. Under type, I want you to pick the very first one that is there. That's just showing you like a scatter plot. We want our x values to be in which list? List 1. We want our y values to be in which list? List 2. Graph, you probably have to hit zoom 9. second stat plot, you're clicking the first graph option. Your list one, X list is list 1, Y list is list 2. Does that look fairly linear? That looks almost perfect. So that just confirms what we decided the other way. My biggest issue with doing it this method on the test, it technically, statistically is a better method. But now you have to correctly draw that on your paper. And that, to me, I could definitely draw you that graph really well if you gave me about 20 minutes. But I can do a histogram a lot quicker. Because I'm going to look for gaps and like the fact that there's one down here and there's a gap and there's two and there's a big gap and they bulk, like that kind of thing. Like you'd have to be looking for all those details in your sketch. So I personally can't do that well unless I literally graph every single point. Like to me, that would be hard to sketch and get all the credit for it. Can you use this method? Absolutely. But I suggest method 1 because the thought process for the level of the depth that we get into this makes more sense. Now, show you something else. Go to second stat plot. The very last graph option, it looks like a line. And now it's only going to ask us for one list. So data list is list 1. Leave your data axis as X. And hit graph again. That's the exact same thing.
It looks less than.
I think they flipped it with X. I think I maybe put it with X and Y switched instead of X axis to Y axis.
It still looks linear, so it doesn't look perfect.
Right. And then it was X axis. It's ours. We use rounded values for your mean, and we use a sample value for standard deviation, and they use not rounded and population proportions. The only thing's different. But that's your exact same thing. So technically, you could have used this if you choose this method and gone with that, because it did the process of the z values for you. Like choosing this graph, the last graph is a normal probability plot, and this does nothing for you. Yeah. Questions about the normal probability plot itself? So things that I need to know that you know. We always have to graph it first. Histogram, whatever stem plot technically can do. What am I checking for initially? And if it looks worthwhile of continuing, the 2 things I'm checking for are bell shape and symmetrical about the mean. From there, I then find my mean and standard deviation to draw my number line, and then find the percent in each section, and then see if that's close to 68, 95, 99.7. If so, then we can use the yellow sheet, or we can use a empirical rule. The other way, normal probability plot, if I ask you, if somebody chooses to do this, and technically I've taught you both of them, they're both in the book, so if you choose to do this on a test or quiz, I would grade it that way, that's fine. Drawing a normal probability plot, the things I need you to know are what goes on the x-axis, the values, what goes on the y-axis, z-scores. So it converts each one to z-squared and graphs against it. And the main thing is, what are you looking for in a normal probability plot? We want it to be linear, and if the normal probability plot is linear, the data is approximately normal.